The Best of Our Knowledge explores topics on learning, education, and research. Coming up, the spring 2024 semester was marked by student protests across the country. We'll speak with an organizer at Bard College, where administration officials reached an agreement with pro-Palestinian demonstrators. And we'll learn about a rare fern with a record-setting genome. I'm Lucas Willard, host of The Best of Our Knowledge. You're listening to The Best of Our Knowledge. I'm Lucas Willard. This past spring saw large-scale protests against Israel's war against Hamas in Gaza that rallied students on campuses across the country. The war that began with Hamas's attack on Israel on October 7th, an event that saw 1,200 people killed and hundreds kidnapped, has led to the deaths of more than 37,000 Palestinians by Israeli forces. The response from college campuses has varied. Some campuses chose to bring in law enforcement to break up student protests. Other campuses, including Bard College in upstate New York, signed agreements with students calling for a ceasefire. Prior to the end of the academic semester in May, the Bard chapter of group Students for Justice in Palestine announced Bard administrators had signed on to SJP's list of demands, following students' occupation of an academic building. Now, with students on summer break, those who graduated say they have hopes for incoming and returning students to continue to make themselves heard. The Best of Our Knowledge's Jody Cowan spoke with Ariella Manis, a Bard SJP organizer and member of the Bard class of 2024.
I'm in the social studies and literature and language fields. I was a co-head for the Students for Justice in Palestine at Bard College last academic year, as well as in the fall semester of this academic year. And I passed it off to younger leadership so that I could both finish my final thesis and also support from a more advisory role and help them, step into their leadership positions. Prior to October 7th, I had always planned to organize the Students for Justice in Palestine. I'd always planned to center that as part of my larger experience at the college. And then after October 7th, it ended up taking up a lot more time and space, but that was something I was always committed to and obligated to.
In that commitment and preparation, did you find yourself able to assist in a way that was needed because of that preparation?
Nobody was prepared for October 7th.
Yeah.
None of us had any conception of the magnitude of that day and the days that followed. None of us could conceive of the impact it was going to have on Palestine, on Gaza, on the Palestinian diaspora, the 5.6 million refugees scattered across the globe, not to mention Palestinian Americans or Palestinians who hold citizenship in other countries. None of us could have imagined the repression and violence that students across college campuses, both in the United States and, again, in many areas of the world, were going to face. None of us could have anticipated the police violence that was going to take place in the streets. But again, on the other hand, none of us could anticipate the way that people were going to rally together and the way that people across so many different backgrounds were going to come together and stand in solidarity with one another under the umbrella of Palestinian liberation. And something that is really important to recognize is that, we always chant that Palestine will be free, but the truth is that Palestine will be freed from within Palestine by Palestinians.
On May 21st, just days before Bard's 2024 commencement, administrators appointed by Bard President Leon Botstein came to an agreement with Bard SJP. Bard College is unique among American universities due to its close relationship with Al-Quds University in Jerusalem. Bard maintains bachelor's and master's degree programs in the West Bank through the university for Palestinian students. The first item on Bard SJP's list of demands includes a commitment from Bard to increase communication surrounding Al-Quds Bard College, provide for the safety of displaced students and faculty, and to provide a pathway for students and alums in America to support the university community in Palestine. Manis tells the best of our knowledge that she and other BARD SJP members have been communicating with students at Elk University, but they seek more transparency.
So BARD has a couple campuses and early colleges, and whenever things happen at those schools, we regularly get updates, whether that is because a great achievement has been made there or a faculty member has died or something, a security concern has happened on the campus. But in the past, students at Elk Woods BARD have experienced raids. They have been tear gassed on campus. Recently, one of the main roads to access their campus was bulldozed by the Israeli Defense Forces. And as a result, this plus a myriad of other factors have led them to have to be on Zoom. And we weren't getting any communications about that. And so they agreed to regular and timely updates from what is going on the campus, as well as establishing a fund for joint projects between students at Annandale and students at AQB, and just generally disseminating more information on local resources and what is going on within Palestine, specifically around AQB.
Student protesters began occupying a lawn on the BARD campus on May 6th. The college maintains that negotiations with demonstrators had already been underway at that point. Manis believes that negotiations did not pick up until students occupied Ludlow Hall, a historic building on campus that has long been a hub for protest and houses the offices of the college president and other top officials. Manis explains.
Some admin discreetly reached out to individuals but did not make any attempt to reach out to the encampment as a whole. And there are multiple modes for doing that. They could have come in person and offered formal negotiations. They could have sent an email to us offering formal negotiations. But nothing of that was done until I believe the 6th day of encampment, at which point we went into formal negotiations. We had 1 hour-and-a-half meeting, and then we were told that the follow-up meeting wouldn't be for another week. And then around that same time, an interview came out on a podcast where the president of the college, President Leon Botstein, was asked, what do you do with nonviolent student occupations? And his response was, you wait them out until they leave of their own accord. And so this reaffirmed our suspicion that they were just attempting to wait us out and to dry us out, that they were not going to use police violence. They were going to rely on student apathy and the ending of the semester and graduation. And so it became apparent to us that if we were ever going to be taken seriously, we needed to have a leverage point. And where we were encamping was not a leverage point. It was not a lawn that was absolutely necessary. And so as a result, we made a decision to occupy Ludlow, which is the main administrative building at the college.
The occupation of Ludlow Hall began on May 17th. Manis says that after students began camping out in the building, the administration began offering back-to-back meetings. After 4 days, the agreement over demands made by the students to BARD College was made public. Other demands met include BARD's continued support of its housing and board for refugee students through its Sanctuary Fund. The college has been assisting displaced students from Afghanistan and Ukraine and has expanded its program to include students from Gaza. The demands also seek transparency in relation to the college's endowment. Manis says as some students graduate and move on, it's up to those students continuing their educations and future students to keep the college accountable.
It's twofold. It's one, making sure they make good on what they said they would do, and then also pushing them to actually do what we asked them to do, which they were not able to meet in the current moment. I'm graduating. I trust entirely in the current leadership and everybody who participated in the Popular University for Gaza to carry this torch and to do it with a lot of grace and a lot of care. And I trust that they will always center Palestine. I could make all kinds of guesses about how the future will be, but I also know that the future of Palestinian liberation is in Palestinian hands, and that students are a tactic, occupations are a tactic, but we are not the movement itself. The movement comes from within Palestine, and we listen to our peers at AQB, we listen to our friends, we listen to our comrades who are Palestinian, and we always make sure that is at the center. Students are a part of it, but we're not the point.
Manis says even if student action cannot halt the genocide, lessons learned by students who are taking risks to speak out for the cause are valuable. For the best of our knowledge, I'm Jody Cowan.
This is The Best of Our Knowledge. I'm Lucas Willard. In the spring, we brought you an in-depth look at how a closing liberal arts college affected students, faculty, and neighbors in Albany, New York. The College of St. Rose operated for more than a century before it closed its doors in June. The private school was just one of a number of small institutions pressured into closure by declining enrollment amid the lingering impacts of the pandemic. With an eye on the campus's future, New York officials worked with local leaders to pass state legislation to create a public authority to help decide the future of dozens of properties. The Best of Our Knowledge's Dave Lucas reports on the Albany County Pine Hills Land Authority.
The authority will be staffed by 7 local members, with 4 appointed by the county executive, 2 appointed by the county legislature chair, and 1 by the mayor of Albany. They will serve 4-year terms. No appointees have been named yet. Albany County Legislature Chairwoman Joanne Cunningham has reached out on social media asking residents to send resumes and cover letters for consideration. The private college shuttered after more than a century, citing low enrollment and financial pressure, but it leaves a significant footprint in Albany, with dozens of now vacant buildings located in the city blocks. At the close of the New York State legislative session, lawmakers approved the Albany County Pine Hills Land Authority to handle the property's future. 109th District Assemblymember Pat Fahey said it is essential to not have St. Rose's fate determined by bondholders Invesco and BlackRock. There were $48 million in outstanding bonds. In the spring, Touro University of New York City had expressed interest in affiliating with St. Rose, but nothing came of it. In May, the college hired international real estate broker JLL, Jones Lang LaSalle, to help the school market its 81-building campus, which the authority could purchase. The Democrat says the situation is fluid and there is a line of interested parties.
The Albany Schools has expressed an interest in some pre-K classes and more. There's the Albany Symphony, the YMCA has expressed some interest. I mean, a lot of different nonprofit and public entities have expressed an interest in the campus. So I see it as many parts, many ideas being pulled together ultimately. But there may be a surprise out there that we're not aware of, that after the realtors market this more, we may see something more.
County Legislator Sam Fine represents the 6th District.
I think that this Land Development Authority is a great idea because it allows us to ensure that these buildings will continue to be put to use, and it gives us the ability to find the right uses for that, whether it is a college campus, which would be great to continue the educational setting of the neighborhood, or housing, which is an important need, businesses, something else, or a combination of all of them.
Questions remain, including whether the authority will conduct open public meetings and if a single individual will be named to head the body. Again, Fahey.
Some of this is up to the bondholders on when or if this goes to bankruptcy court. That remains a fluid situation too. They may decide to wait to see what JLL, the realtor, comes up with by September. I know that the JLL realtors were just beginning that marketing these, in this last month.
JLL did not immediately respond to WAMC's request for comment. Reporting for the Best of Our Knowledge, I'm Dave Lucas.
This is The Best of Our Knowledge. I'm Lucas Willard. A rare plant has set a new record in the scientific community. Discovered on an island in the southwest Pacific, the New Caledonia fork fern has the longest genome measured by scientists. The genome of the humble fern is larger than the most towering of trees, the mightiest of mammals, and the most fantastic of fungi. To learn more about this super species and the rare habitat where it's found, I spoke with Dr. Ilya Leach, a senior research leader and plant genetics researcher at the Royal Botanic Gardens, Kew in London.
New Caledonia is about 750 miles east of Australia. It's an island. I have to admit that I wasn't lucky enough to go there to collect the plant. That was done by my colleagues, Jaume Pellicer and Oriane Hidalgo, and their PhD student. But it's an island in the middle of the Pacific, I guess. So that's where you need to go to find it. It's an independent part of France, actually. Independent, what do they call it? An island nation of New Caledonia, which is an overseas French territory.
Because it's an isolated island 700 miles off the coast of Australia, did this clue you in on, say, well, because it's a more rare species, it could have a more complex genome? Or are ferns in general more complex than other plants?
I would say that ferns are certainly different from other plants in terms of how they organize their genome and how it evolves, and that impacts on the ferns themselves. For example, ferns have a much greater diversity of chromosome numbers. That's the chromosomes are the packages of DNA that a cell packages their DNA into. So that we have, for example, 46 chromosomes in each of our cells, and our DNA comes from our two parents. So we're said to be diploid. So we have two copies of our genome in each of our cells. But ferns, they have a huge range in chromosome numbers. In fact, the highest chromosome number for any plant is found in a fern with 1,400 chromosomes in each cell. So that's a huge, much greater variation than we find in flowering plants, for example. And they do this process, which is common in other groups, but particularly common in ferns, called polyploidy. And that just means that they have more than two copies of the genome in each of their cells. We have two copies, as I say, one from our parent, one from each of our parents. Now, in some ferns, they have 96 copies. So it's a real conundrum as to what's going on, but certainly they are distinctive in how they organize their DNA and how it evolves compared with other with other groups, such as the flowering plants.
So back to the fork fern,
yeah.
Because this plant is from a rather isolated place, did you have an idea that it would have a more complex genome?
Well, when we say more complex, I'm not sure we know how complex it is yet, because all we have done so far is to estimate the genome size. So we know how much DNA there is in there, but we haven't yet been able to sequence that DNA to look at what types of DNA sequence make up its genome and how they're organized. And maybe it isn't so much more complex than many other ferns and many other plants, in fact, in terms of the number of genes that it has. So genes are the bits of the DNA which codes for proteins, which sort of underpin how all organisms live. They probably don't have a significantly higher number of genes than we do in our own genome. So it's not the number of genes, it's what is the DNA that makes up the rest of the bulk of the genome that is really intriguing, and what we would really like to know and understand more about if we are able to sequence the genome.
I think it might come as a surprise to some folks who are not as familiar in the world of genetics and DNA that a plant would have a longer genome than, say, an animal or a person. What are the most simple organisms when it comes to length of the genome versus the ones that have the longest genome?
So the simplest, if we convert the amount of DNA into a length, would be a type of fungus, which is an obligate parasite, so it has to be a parasite, that lives inside, in fact, human intestinal cells in our intestine. Some people can be infected by it. And it has a tiny genome, probably just a few millimeters in length. So that's the smallest that we know so far. That, of course, is excluding bacteria and viruses, which can be even smaller than that. So I'm talking about sort of cellular life, where the organisms package their DNA within a nucleus. And then, of course, the record holder, the biggest genome for any plant is the fork fern, but it's certainly bigger than the biggest in animals. So the biggest in animals is found in a lungfish, perhaps surprisingly. Anyway, there's a lungfish which has a genome that is about 130 gigabases. So the fern is this fork fern is 160 gigabases. And just in case it's useful, gigabases refers to the number of letters of the DNA code that are present in its genome. So our own genome is like three gigabases in size. So 3,000 million letters of the DNA code. The biggest, as I said, in animal is a lungfish, although there are also some big genomes, but not quite as big in salamanders, in some salamander groups. But the plants seem to have it when it comes to record holders. And that's why, in addition to, this has been given the Guinness World Record for having the biggest genome for any organism on this planet. But as you can see, there is really no relationship between genome size and organism complexity. And certainly, as I was saying earlier, the number of genes, these bits of DNA that code for proteins, doesn't vary hugely. Certainly with humans, it's estimated that we have about 20 to 25,000 genes. And this fern probably, we'd estimate, maybe have as high as 100,000, but we don't really know exactly. But it's not going to be probably much bigger than that. So it's not a big increase in number. And in fact, in terms of the amount of DNA that codes for these genes, even in our own genome, those 25,000 genes are making up only 2 to 3% of the DNA. So the rest of the DNA, lots of other things going on there. And in the fern, probably only 0.5% of the DNA is actually coding for genes. So the complexity is difficult to define at a genomic level. It's not to do with the number of genes. That's something that we're pretty sure is not the case.
Now, if I remember back to biology class, ferns appeared on Earth before flowering plants. Does the amount of time that an organism has been on Earth, does that correlate to the length of its genome?
No, it doesn't. That's something else that we have discovered. It seems that, in fact, the most common type of evolution is that bigger genomes are arising from two processes. One is this polyploidy, the accumulation of more copies of the genome. That makes the genomes bigger. That's one way that you can get bigger, but often the result of polyploidy is that over time, the genome responds by kicking out bits of DNA. And so it gets small again. And so that's one way, but it doesn't lead to ever increasingly larger genomes. The other way is through the amplification, making lots of copies of some of this DNA that is not coding for genes. And these are sequences which are present in hundreds to thousands to millions of copies in the genome. So we call this repetitive DNA. And these have the ability to make copies of themselves, amplify, and then insert elsewhere in the genome. Now, in most species, what we know from studying species with small genomes, once again, you get this amplification of repeats, they get bigger, but then the genome has a counterattack. It can eliminate them, and so it gets smaller again. But in the case of these really enormous genomes, it seems that they get, after a certain genome size, they accumulate these and they can't get rid of them. But it doesn't seem to depend on evolutionary time. So most species having small genomes, and those with big genomes, appear relatively recently in the evolutionary record, with perhaps the exception of the lungfish, where they used to be a much more diverse group than now. There's perhaps, I can't remember, maybe 10 or 15 species of lungfish. And in the past, from the fossil record, there's evidence of lungfish with genomes of all sizes. We can see that from the size of the cells that are in the fossils that you can detect. And the only ones that are surviving today are really big genomed lungfish. So it's interesting that there's over evolution, different things are happening in different groups of organisms, but certainly it's not if you've been around for longer, you're going to have a bigger genome. That is not the case.
So Dr. Leach, now that you've found the record holder, is your research going to take you back out to find the next maybe organism that has the longest genome, the new record setter, if you will?
I think, well, we'd certainly like to make complete analysis of genome sizes within this fern genus Mesipteris, the hanging fork fern genus, but there are only 15 species. We're really interested to do is to see, about the types of DNA sequence that make up these enormous genomes. Well, how are they organized? How are they evolving? And what are the consequences to the plant of having so much DNA? How does it affect their evolutionary trajectory? How does their ability to form new species? And really understand more about their biology. Because we know really quite a lot now about species with small genomes, but we're suspecting that these species with really big genomes are doing something different. And if we're to conserve plants, which, underpin all of our lives because it provides all the oxygen, the clothes, food, and things that we need, we really need to understand genomes of all sizes in order to understand how they evolve and therefore how best to conserve them. So that's really, I think, where our focus of research is going to go now, hopefully. Anyway, that's the challenge. We have to raise funding for it. Of course, like all science, we need to raise money to do the research, but that's what we would really be excited to do and can therefore contribute to understanding genomes of all sizes that live on this planet.
Dr. Leach, thank you so much for taking the time and best of luck with your research.
Well, thank you very much. It's been a pleasure talking. Thank you.
Dr. Ilya Leach is a plant genetics researcher at the Royal Botanic Gardens, Kew, in London. You're listening to The Best of Our Knowledge. I'm Lucas Willard. If you'd like to tell The Best of Our Knowledge what you think, send us an email at knowledge@wamc.org. You can listen to The Best of Our Knowledge anytime as a podcast, downloadable wherever you get your podcasts. If you want to catch up on past episodes or hear more WAMC National Productions programs on the news, academic study, books, women's issues, the media, and the environment, visit wamcpodcasts.org. This has been The Best of Our Knowledge, episode 1764. The Best of Our Knowledge is a national production of WAMC, Northeast Public Radio. Thanks to associate producer Jody Cowan. The latest on all National Productions programs is available via the Airwaves newsletter and our flagship station's website, WAMC.org. Until next time, I'm Lucas Willard.